The main focus in this chapter is on static systems, in other words, objects that are at rest and remain at rest. You might recall that Newton's first law talked about an object that is in inertial motion is one that is either at rest and stays at rest, or one that is in motion and stays in motion. So in this case, we're just looking at the special case of something that is at rest and staying at rest. And in light of that, the stuff we see on the key concepts page here, and I'm going to go into some of the what the math notation means in more detail over here to the right. That really is something we've seen before under Newton's first law, right? This is, if we know an object has no net force on it, we know that it means its acceleration is equal to zero. In other words, it's going to stay in the state of motion that it's in. But if that happens to be that it's at rest, it's going to remain at rest. So naturally, that is also the condition for an object to remain at rest. And the topic title is force balance, which I think is a conceptual way of saying, what do we expect for an object that is going to stay at rest? We expect that the forces must balance. So this is one of the, you could say, sets of criteria for an object to be in static equilibrium. And so again, we have the familiar net force is equal to zero. Underneath that, though, I've written this with summation notation, which is basically an abbreviated way of saying that the net force is the sum of forces. In other words, these two lines really say the same thing. They're just different ways of saying net force. So on the whiteboard part, I've written here a line that says F net is equal to this sum. Here I was looking at maybe a specific example. I left it somewhat abstract, but I drew an FBD up here with three forces in it. And so for three forces, like the way this summing notation works, the summation notation, is we're thinking about some index variable I that runs from 1 to the total number of forces that you have. And in this case, there's 3, so that means 1 to 3. And we're summing over all those forces, each one of them indexed with that indexing variable I. But what that really means is I'm just going to do f sub 1 plus f sub 2 plus f through 3. So 1 through 3, in other words. And then the condition is for statics is that that should be equal to 0. The last two lines here, this is commonly seen in some engineering textbooks, and it's what we're going to actually use. So in that sense, if you say, like, what do I really need to know? Maybe just the last two lines. Because they're saying really what we're going to do is we're going to be able to get one equation by summing the x components of the forces and setting them equal to 0, and another equation by summing the y components and setting them equal to 0. So in most problems, we're going to probably have a sketch or a picture or make our own. We can draw an FBD, and then from that information, we're going to be trying to write down up to 2 equations summing up the components of the forces and setting them equal to 0. I say up to 2 because it's possible to have maybe a one-dimensional example, but I think in this chapter we're going to often be a little bit more two-dimensional.